Hi everybody, welcome back to our YouTube channel. In today's video, I am going to solve today's Leetcode problem. Today's Leetcode problem is 567 permutation in string. So let's try to understand the problem statement and we will discuss the approach of solving this problem. So in the problem statement, we have given to a string s1 and s2, okay? And we have to return true if there is a condition that s2 contain a permutation of s1. S1 string has so many permutation, and if so many permutation, and if any permutation exists in the string s2, then we have to return the true, otherwise return the false. Okay, so let's try to understand the problem statement. See, in this example we have s1 is equal to ab and s2 is equal to this. So we have to find all the permutation of s1. So s1 permutation is ab or ba. So these are the two permutation of s1. So we have to check whether any of the two permutation exist in the s2 or not. So if I consider these things ba, here ba exist in the s2, so in this case we have to return the true. But if I consider this example, then s1 is also ab, so their permutation is ab and ba. So we have to check whether any of the two permutation exist in this s2 or not. So if I considered if I check to see no one from this permutation exists in the s2, so in this case we have to return the false. Okay, so let's understand this problem in the whiteboard. Okay, let's see the problem statement. So basically we have given to a string s1 and s2, and we have to check whether the permutation of a string s1 exists in the s2 or not. So one of the very naive approach that came to our mind is that if I generate all the possible substring of length 2, because see s1 has length 2, so the permutation of s1 is also have length 2. So if I check all the possible permutation, all the possible two length substring, all the possible two length substring from the s1, and after that we will check whether the element in the s1 is equal to the equal to any of the possible length 2 substring from the s2. If any of the possible substring matches with the s1 character, then we have to return the true. So this is a naive approach, and see, and this is a very much time consuming as well. So we have to optimize this approach, because see, if you try to check all the possible substring of length 2, then it takes lot of time, because see, if I consider this example that e I d b a o o o, so for this the first substring is this much, and after that the substring is this much, and after that this two length of substring like that. So it is a time consuming approach. So let's try to optimize this approach, and we will see the algorithm that how to solve the problem using that approach. So see, if you notice something, that we have to check the permutation of the string s1. So if any string is permutation of any string, then all the character of original string is equal to the all the character of the permutated string, because the character are not differ from the original and the permutation of the string, because the permutation is basically the rearrangement of the character. So if the original string is ab, then their permutation is ba. Only the rearrangement of character occur, but the every character occurs equal number of time in both of the string. So if I try to solve this problem using the sliding window technique, then it may take very less time as compared to the previous algorithm, because in sliding window what I will do, we check every sliding window and after that we move till the end. Okay, so in the sliding window, suppose, yeah, if I put the character of the S1 in the unordered map, suppose AB, and the occurrence is 1 1, and also we know that the length of the S1 is 2, so we have to check for every sliding window of size 2, and after that we also put for every sliding window we put the character in another unordered map. Suppose if the one unordered map is ms1 and another is ms2, so for every sliding window, every window of size 2 we put in the unordered map and check whether this two unordered map matches or not. If both unordered map are equal, then at that position we have to return the true, otherwise we have to return the false. So in the sliding window technique, how to solve this problem using sliding window. So if you know about the sliding window, then in the sliding window we take two variables, that is I and j. Okay, and after that, see, so suppose I have to apply the sliding window for a string s2. So see, the length of the string is 1 2 3 4 5 6 7 8. Okay, so length of the sliding window is 8, n is equal to 8, so we apply for sliding window like that. See, then we iterate, take a map also s2, and after that we iterate till j less than n. Okay, now after that, while iterating from the s2 string, we push the character of the s2 string in the map. So let's take a map. Okay, and after that, first j is equal to 0, j is equal to 0, then at the 0 index the character is e. To push the character in the unordered map, so its occurrence is equal to 1. Okay, and after that we check whether the window size is equal to the size of the string s1 or not, because if I wanted to check the substring, permutated substring of s1 in the s2, then the size of the length of s1 as well as s2 is equal. So we have to check whether the window size is equal to the length of the string s1 or not. Here the length of the string is s1 is 2, to check whether two window size. So how we find the window size? So window size will be find using the j minus I plus 1. Okay, j minus I plus 1 is the window size. Okay, suppose, see, if I consider this example that let me check, EIDBAOOO. So see, initially I is equal to 0 as well as j is also 0. So window size will be of length 1. So we have to find the window size like j minus I plus 1. So j is 0 and I is also 0 and 1. So window size of length 1. So see, window size is not equal to the 2, so we have to increase j plus plus. So j plus plus will be now at here at index 1. If I try to write the index, then let's change the color so that it will be better understanding. So this is 0 1 2 3 4 5 6 7. This is the index. Okay, so now j is pointing to this position. Okay, j is pointing to at 1. So now the window size is j minus I plus 1. So j is equal to 1, I is 0 and 1. So window size is 2. So window size is equal to the length of s1, that is 2. So we have to check and also push whenever we move the j value, we push the element in the unordered map and also the count of that character. Okay, so if we hit the size is equal to 2, so window size hit the size is equal to 2, then we have to check both the map, that is ms1 and ms2. Let's suppose name is ms2. If both the unordered map are equal, then we have to return the true, because If both the unordered map is equal, it means that the whatever the element occur in the S1, that element occur in this window that we get right now. So right now we get the window is equal to EI. Okay, so check whether both the map are equal or not. So see here, both the map are not equal. If both the map are not equal, then we have to check whether some other substring exists or not, that is permutation of the string S1. So for this we have to increase the j value. Okay, so here if I increase j value is equal to 2, then now our window's length is equal to 3, that is greater than the 2. So now we have to reduce the window size, because we need the window size is equal to 2, because we have to find the permutation of this string. So this string length is 2, then we have to get the permutation of permutation length is also 2. So now we have to reduce the window size. So for reducing the window size, we increase the I pointer, because I pointer is pointing to 0 location. So we increase, before increasing the I pointer, we have to reduce this occurrence from the unordered map. So E is occur in the unordered map, so decrease the counter of E is equal to 0, and whenever the character in the unordered map count is equal to 0, then we have to erase that character. So right now we erase this character. Okay, and after that we again hit the windows of size 2, then again check whether this unordered map match with, whenever we reach the j pointer, we also put it in the unordered map, so D is also 1. And after reaching again the 2 length size, we have to check whether the 2 map equal or not. So here both the map are not equal, then increase the j pointer. So now j pointer is pointing to 3 location. So now the window's length we get is equal to 3, because I is pointing to location 1 and j is pointing to 3 location, so we get the window of length 3. So also whenever we reach any new character of j, we put it in the unordered map. So B has also occurrence of 1. Okay, so 1 occur, and after that we see the window's length is greater than equal to 2, so we have to reduce that window length. So for reducing window length, we increase the j pointer, we increase the I pointer. So before increasing the I pointer, first we reduce the count variable of the ith character. So the ith character is I, so reduce the count variable is equal to 0. So whenever we hit the count variable of any character is 0, we erase that character from the unordered map, and after that we increase I plus now pointing to 2, again hit the window size 2, then check whether the unordered map 1 and 2 equal or not. So here the unordered, both the map are not equal, because here B occur one time, also B occur here also one time, and here 1 occur one time, but here D occur one time. So both the map are not equal, then again increase j now pointing to 4 positions. So we have to also put the jth pointer character in the map and whose count is 1, and after that we check we get the window's length is equal to 3, because I is pointing to location number 2, so we get this value, that is DB8. So I is pointing to this location and J is pointing to this location. Whenever we get the windows size is greater than the 2, then we have to reduce the window size. So for reducing the window size, we increase the I value. So before we increasing the I value, we have to reduce the occurrence of the ith character from the unordered map. So see, the ith character is D, so we reduce that character is equal to 0, and whenever we hit the character count is equal to 0, so we erase that character from the unordered map, and after that we increase the I value. So now I value is pointing to this location, and we hit the window size is equal to 2. Whenever we hit the window size, we check the unordered map 1 and 2. So see here, unordered map 1 contain B occurs one time and A occurs one time, and here if you see the map 2, so here also 1 occur one time and B occur one time. Then whenever hit the windows, whenever the ms1 barabar ms2, then at that case we have to return true. So at this position we have to return true. Okay, so we get the true from this string s1 is equal to ab and s2 is equal to s2 is equal to this much. So it means that we get the permutation of a string s1 in the string s2, and if I iterate till this position, and whenever we are not getting any of the character that matches ms1 barabar ms2, then at finally we have to return the false. So I hope you all understand the problem algorithm, that how we will proceed to solve this problem statement. Okay, if I summarize this algorithm, then see what I will discuss in this algorithm. This algorithm is based on sliding window. Okay, for sliding window, this is a that's like technique that we take two pointer, that is I is equal to 0 and also j is equal to 0, and we run a loop till j less than n, that is size of the h2 string, and after that whatever the character at the jth position, we push that character in the map. So if nums, sorry, s2, here this is not a vector, so we take s2, so s2 of j plus plus. Okay, and we have to check at every iteration the size of the windows or not. So for finding the size of the window, we check if j minus I plus 1 less than equal to k. What is k? K is the size of the s2 string. Okay, if j is if the size of the window is less than k, so we have only one option to increase the j plus plus. Okay, and whenever we hit the size is equal to k, then we have to check to map ms1 barabar ms2. Okay, and if both the map are equal, then we have to return the true. Okay, and if not, and whenever we get the window's length greater than k, then we have to reduce the window's length from the from ith pointer. So what I will do, that we before increasing the I pointer, we have to reduce the whatever the character occur at the ith pointer from the map, we have to reduce, and whenever the count of that character is equal to 0, then we erase that character, and after that again check whether the ms1 is equal to ms2 occur or not. If occur, then we have to return true, and after that we increase the j plus plus. So these are the summary of the previous algorithm that I have discussed. So let's try to see the code for better understanding. So whatever I have discussed, I will write the code of that algorithm. So see, first find the length of the string s1 and s2. Sorry. So the length of the s1 is denoted as k and length of s2 is denoted as n. So we take two unordered map of character in ms1 and ms2, and whatever the element in ms1, we put it in the ms1 map, and after that we take two pointer I and j for sliding window. Then we iterate till j less than n. Okay, and after that, as I have discussed, that whatever the element at jth position, we push it in the second unordered map and increase the counter, and after that we check the sliding window, the length that is j minus I plus 1. If less than equal to k, increase the j plus plus, and whenever we hit the sliding window of size k, then check whether ms1 is equal to ms2 or not. If this happens, then return true, and after that we increase the window's length, and after that when the window's length is greater than k, then first we have to reduce the ith pointer value from the unordered map, and after that check whether the map count is equal to 0 or not. If map count is 0, then erase that character from the map, and after that increase I++. Then again we hit the map of size k, then check whether the both the map are equal or not. If equal, then return true, and then increase the size of the windows, and after that if this condition returns nothing, then it means that there are no permutation of h1 exist in the x2, then at that position return the false. Okay, so I hope you all understand this problem statement as well as algorithm that I have discussed till now. So let's try to submit the code and see whether it will be submitted correct or not. So it will be correct for this test cases, and if you try to submit for all the test cases, then it will submit it for all the test cases as well. So thank you for watching the video. See you in the next video.